For as long as we've looked at Saturn, its rings have been its crown, bright, wide, monumental. Even early telescopes revealed them as shimmering arcs that set Saturn apart from every other planet in the solar system. But now, for the first time in nearly 15 years, those rings are vanishing. Not slowly, not figuratively, literally disappearing from view. And if you step outside and aim your telescope at Saturn during this rare alignment, you'll witness something that only happens a few times in an entire century. Its rings collapsing into a razor-thin line, until they nearly vanish entirely. This is one of the most dramatic astronomical illusions we ever get to see, and it's unfolding right now. The reason Saturn's rings are fading isn't because they're physically disappearing. Instead, the planet is slowly rotating into an orientation where we see the rings edge on, a geometric trick created by the tilt of Saturn's axis as it orbits the Sun. If you took a sheet of paper and held it flat, it would look wide and bright. Rotate it until it's edge on, and it becomes nearly invisible. Saturn's rings behave the same way. Most of the time, we see them at an angle, tilted toward us or away from us, making them appear large, bold, and radiant. But every 15 years or so, Saturn enters a phase where the rings align perfectly edge on. The tilt goes to nearly 0 degrees. The reflective surface area collapses, and the rings fade into a thin, almost ghostly line. To the human eye, and even through telescopes, they simply disappear. Saturn takes 29.5 years to orbit the Sun. As it travels, the angle of its ring plane shifts relative to Earth. At certain points in this orbit, we cross the ring plane, the same flat disk in which the rings orbit. During these moments, called ring plane crossings, the rings look like a sliver of darkness or a thin white scratch across the planet. And that moment is happening right now in 2025, with the rings approaching maximum flatness, the lowest angle seen in years. This arrangement hasn't occurred since 2009, and after this alignment passes, the rings won't vanish again until the 2040s. To an astronomer, that makes 2025 a once-in-a-generation event. The rings are made of billions of icy particles, ranging from dust grains to house-sized boulders. When they are angled toward us, sunlight reflects strongly off the icy surfaces, making the rings bright and easily visible. But when they rotate edge on, reflective area drops to nearly 0. Instead of a wide reflective ribbon, we see only the thin vertical thickness of the rings, about 10 meters to 1 kilometer depending on the region. 2. The rings dim dramatically. With less sunlight reaching us, they lose nearly all brightness. 3. Earth-based telescopes lose contrast. Even professional telescopes see the rings fade into the glare of Saturn itself. 4. The rings cast thinner shadows. Saturn's iconic ring shadow, normally a dark arc across the planet, collapses into a fine line. The majestic wide rings suddenly look like they've been erased. This ring disappearance comes at a time when planetary scientists are studying something even more mysterious. Saturn's rings really are fading permanently. NASA's Cassini spacecraft measured a phenomenon called ring rain, where particles from the rings slowly fall into Saturn's atmosphere due to magnetic and gravitational forces. Saturn is literally consuming its own rings. Scientists estimate the rings may last only 100 to 200 million years more, a blink in cosmic time. So while the 2025 disappearance is an optical illusion, it echoes a much deeper truth. Saturn's rings are aging, changing, and eventually they will be gone. While the fading rings disappoint sky watchers, astronomers are excited. Ring plane crossings offer a unique chance to observe 1. Saturn's moon system more clearly. The glare from the bright rings usually washes out tiny moons. During this event, several small moons become visible. 2. Vertical ring thickness measurements. This angle allows scientists to measure the physical thickness of the rings, something impossible at other times. 3. Ring shadow dynamics. The nearly invisible shadow helps study atmospheric absorption on Saturn. 4. Searches for faint new ring material. Edge-on alignment makes small debris detectable as they catch sunlight. Depending on your telescope and location, the disappearing rings will appear as a thin dark line slicing across Saturn, a faint white scratch at the equator, a barely visible ripple, or in smaller scopes, nothing at all. Saturn will look more like a smooth beige sphere, almost alien without its signature crown. For many amateur astronomers, this will be the strangest Saturn they'd ever seen. As Saturn continues its orbit, the rings will slowly regain their tilt. Over the next year, they'll begin to reappear, widening month by month. By late 2026, we'll once again see the rings at a noticeable angle. By 2027 to 2028, they'll be back to their full glory. And Saturn will look like its old self again. These long cycles, decades of opening, closing, tilting, and flattening, remind us that the solar system is not static. It's a giant machine in motion, governed by geometry, gravity, and time. Saturn's disappearing rings are a cosmic mirror, a reminder that everything we see in the sky is temporary. The phases of the planets, the tilt of their moons, the glow of comets, even the rings of Saturn themselves, nothing is fixed, nothing is permanent. The universe is in motion, and we're lucky enough to watch it, frame by frame. So when you look up this year and see Saturn missing its famous rings, don't be disappointed. You're witnessing a phenomenon that most humans will never see. A perfect alignment of sunlight, tilt, and celestial mechanics. A once-in-decades cosmic illusion. And in that illusion lies one of the most beautiful astronomical events of our generation.